Hello and welcome everyone. Thank you all so much for joining us today for this live stream event. My name is Alexia and I am the project and event manager at Microsoft Reactor Toronto. Before we begin, I'd like to quickly review two items with you, our code of conduct and our event guidelines. Please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Our event guideline. This session is recorded. It will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link of our channel later in the chat. And if you've not been on a live stream through YouTube before, please note that you must create an account on YouTube to access and interact in the chat. If you are unable to use the chat but have any question, feel free to reach out to us on social media or on Meetup. And this brings us to today's session. I'm going to bring in our speaker here, Renee. Hi there. How are you today?
Doing great.
Fantastic. Well, we're super excited to have you here all the way from Germany. I will leave the floor to you.
Awesome. Well, thank you so much for this fantastic introduction. Hey, everyone. My name is Renee. I would say let's get started. I will roll a quick video to get us pumped up for the session, and then I will tell you actually what we're going to talk about. But let's roll the video first to get us in the right enthusiastic mood. Well, I love this video. We just made this video showing some showcases basically for some of the Metaverse work we're doing. And so in this Future of Computing talk, we're going to talk about spatial computing, including the Metaverse, of course, because there's no way we could not talk about the Metaverse these days, right? And so spatial computing and the Metaverse is around a 5 to 10 year horizon or something like that. And of course, these Metaverse solutions will require massive computational power. Like you want to run simulations, or you might actually want to also have true randomness. And quantum computing might be capable of doing that, right? And so we're going to talk about in the second part of this session about quantum computing. And this is just a basic introduction. I'm going to show you the basics of quantum computing. What is a qubit? But also certain impactful things where quantum computing can already achieve a significant value today. And so I'm going to show you a bunch of different key areas and use cases and make this hopefully a little bit less abstract. We're not going to talk so much about hardware for quantum computing, but rather going to focus on the software side of things with quantum-inspired computing and alike. But first of all, we're going to start with spatial computing, like I mentioned, and all things Metaverse. Because all these things might sound like quantum computing, spatial computing, Metaverse, distinct topics, right? But they have one thing in common. They will change computing forever, and they will also change how we humans interact with computers, right? And that's why I combined these two things into one talk about the future of computing. If you don't know me, my name is Renee. I'm Director of Global Innovation at Valorum Reply. I'm also leading the spatial computing community of practice for Reply. I'm also a Microsoft MVP for mixed reality and also a regional director for the Microsoft Regional Director Program. And I'm an advisor for the Aeon AR Association, as well as the XR Bootcamp. By the way, tonight we have with XR Bootcamp, there is the celebration ceremony for the latest kind of folks that finished the courses for HoloLens development, in fact. And so you might also want to join that. I think it's in 2.5 hours or so. The celebration starts with the folks that finished the XR Bootcamp courses with our friend Sean Ong, by the way. Anyhow, so talking about a lot of spatial computing stuff now, and so let's get started actually. But before we do that, we need to talk about what is spatial computing actually. What is Renee talking about here? Well, if we go back a little bit in time, you might remember the 1990s or end of 1980s or so, when a lot of people had their first computer at home, and personal computing really became a thing once they became connected with each other through the internet. And Web 2.0 really changed the game and democratized knowledge sharing, as well as enabled a lot of folks to learn and be wherever they wanted to be, right? But still, you couldn't take computing with you. And that changed when mobile computing came along, especially with the first smartphones like BlackBerry, but in particular with the first iPhone 2007 with touch input. That really changed the game and made computing mobile. Plus, we also get some contextual information. Think about certain sensors in these devices. A sensor, for example, like a GPS sensor, which is providing you the geolocation of the device, right? And already provides you some contextual information. But that is in a very coarse range, like meter range, precision, or something like that, right? And what we really want is a centimeter range like precision. And we can achieve this now since we're entering the so-called spatial computing age, right? After personal computing, mobile computing, now it's the time for the spatial computing age. And this is fueled by intelligent edge devices that can sense the world around us in much more detail. And this can be a device like I have here in my background, Microsoft HoloLens. I'm sure you have all seen it. But the fantastic displays and all of it. But what I want to focus with spatial computing is like these kind of sensors, right? Depth sensor, but also the tracking cameras. They constantly scan the world around you and sense it. And so these mixed reality or augmented reality devices are capable of generating a spatial map, a map of your surroundings. And with this, you can provide, depends on the environment, like let's say centimeter range precision, right? And can basically provide virtual objects in the real world very precisely. But also these VR devices like the Meta Quest 2 I have here, has also a bunch of tracking cameras where it can track itself in the room. So if you put it on and move around, it will know that you moved around and will adapt the scene, right? So it's also spatially aware. But that also actually applies to these mobile phones, right? This is just a standard Android phone. But you also have Android phones or the high-end iPhones. They even have dedicated depth sensors like time of flight or LiDAR cameras. And they can also sense the world around us. But even without this special sensor, without a depth camera, these devices can sense the world around us thanks to computer vision AI. And so it will know, okay, there's a wall behind me, there's a ceiling, there's a floor, and reconstruct this environment, and then can provide much more precise contextual information to the user, right? And so this is the key here. We have intelligent edge devices driven by AI, computer vision, that sense the world around us and provide meaningful things where we can build experiences on top of it, right? And it doesn't really matter what kind of device we're using. You might have a mixed reality device like the HoloLens 2 here, or you can use a tablet, or like I said, a VR device, right? If you look in the scene here, the lady is using a HoloLens, gentleman, large phone or tablet, but they have this kind of same spatial map. These devices have the same map about the environment, and so they can see the same virtual content at exact same positions, right? Since they're spatially aware. And so the form factor doesn't matter so much. Of course, a head-mounted device is a different user experience than on a mobile phone with a small screen, but they're all spatially aware. And all of these devices, VR, AR, mobile, whatever, can be part of the metaverse, right? And you might wonder, what is the metaverse, in fact? You hear it all the time these days, right? And you probably have seen like 100 definitions of it. And I just picked two here, the one from Gartner, the market research company, which I think defines it pretty well. And so the metaverse is this collective of virtual shared spaces, which is a convergence of virtual and physical reality, right? So this is the key here. We're basically combining both. It's not just purely virtual. Of course, you have certain experiences which are pure virtual. But the key is the metaverse is device independent. So you can use it with a VR device, with a Quest, or with a HoloLens, or with your mobile, or with your PC. And the most important part is persistence. These objects need to stay where they are. For example, if I'm in a virtual world, in a Metaverse platform, I have a virtual microphone, I drop it on a table. If I come back 5 days later, it still needs to be there, right? It needs to be persistence. Same applies to your virtual characters, right, in these virtual worlds. And simply put, the Metaverse is the new immersive internet where you can go into with virtual reality, or it can come to you as part of augmented reality, right? And as part of the Metaverse, we have these 7 different layers. You might have seen it before, these kind of seven layers here for the Metaverse. But basically, you have the 4 at the bottom. You have the 4 infrastructure pieces or technology pieces. Like, of course, high network connectivity is needed. You want to exchange a lot of data with low bandwidth. You have the whole human interfaces with different form factors like AR, VR glasses. You have decentralized protocols like blockchain, but could also be other decentralized protocols. NFTs, of course. Spatial computing with all the sensing around us, spatial computing, like I mentioned, spatial mapping and that kind of thing, providing the more computer vision contextual information. And then on top, we have the free, like, let's say, more user experience pieces like the creator economy, right? Like folks can actually quickly create custom worlds, custom metaverse world, custom characters, assets, share them, and so on, right? And of course, advertising, social media, the whole discovery is important for all these different experiences, which could be gaming, could be these MMOs, right? Massive multiplayer online games. Or it could also be enterprise play, like, let's say, corporate virtual spaces and whatnot. So there's a lot of stuff. And Gartner thinks this will be a huge market. And I actually agree. Like in 4 years, they say 25% of the people will spend at least 1 hour per day in a metaverse solution doing different things. And that might actually be true if you consider this also includes MMOs, right? So might actually be more than that. We'll see how that turns out. Of course, always a kind of speculative prediction here when it comes to these kind of things. No one has a crystal ball, right? But of course, this is based on real data. Also, Bloomberg says it's an 800 billion opportunity in 2 years. So, everything is pointing that this is going to be huge. And this is not just based on made up data, but in fact, we're already seeing high return of investments. And I just picked a slide here that has some data for the mixed reality platform. And as you can see, there are some really impactful time savings. Sorry for that. I have a little bit of a sore throat today, so gotta drink sometimes in between here. Yes, so one example I wanted to highlight is the Lockheed Martin piece you can see on the bottom left. This has an interesting time saving. So basically, Lockheed Martin and Boeing are building the Orion space capsule, and they're leveraging the HoloLens. There's actually a fantastic video you can find online where they're showing it. And they're basically put on the HoloLens, and then they're overlaying a virtual grid on top of the space capsule to actually do a quality assurance. And that saves them 90% of the time because they don't have to do it manually, right? So huge time saving, already achievable with these kind of spatial computing experiences. And like I said, pretty much everyone has a spatial computing device like these mobile phones with advanced AR capabilities that can sense the world around you, provide you surfaces like walls and so on to provide you this kind of contextual information. It's around 2 billion, right? I pulled this data, I don't know, like sometime 6 months ago or something like that. So it's even more, right? But if you look at the Quest 2 device here, it looks tiny, right? 10 million. That was a prediction from Qualcomm November, end of last year. And so 10 million is nothing if you compare it to the mobile phones. But just think about it. 10 million people already have such an advanced virtual reality device, right? And so it's actually quite nice. And also Snapchat is saying, hey, this is just going to grow further. We will have a huge impact with AR. And in 3 years, 75% of the global population is going to use AR, right? Might sound also very optimistic, but Snap has actually a good track record of delivering and has a good track record also of their estimations. And of course, if you also consider things like Google Lens or other AR experiences, or like lightweight AR, I would say, which you would technically actually not call AR, but they overlay virtual stuff like the translation feature, right? Virtual translated text on top of the real world. So if you include this, easy 75%, of course, right? The Metaverse is already here, folks. You might not have seen it, but you might have played it. If you look at these large online gaming worlds, it's virtual worlds, virtual characters. Only the asset exchange and the decentralized part might be missing, and also the different use cases. But this is definitely the beginning here, and you can play these games, Minecraft as well, right, on different platforms, device independent, and have virtual characters in virtual worlds, right? So you already have kind of an easy path into this. And in fact, you can actually already create your custom worlds. You can engage your corporate spaces there. And here, for example, you can see our own Reply. This is the Reply logo, right? The little running man there. And so in Roblox, we created our own corporate space there where we can internally hang out, but also at some point, maybe also meet clients there, right? And so you can build these virtual worlds already in these kind of gamified experiences. Second Life again, kind of, right? And you have, of course, dedicated stuff from companies like Facebook that rebranded themselves to become Meta. They even changed the name of this device, which had actually a fantastic name before. It was called the Oculus Quest, the Oculus. Just think about the Oculus, right? I mean, this is a perfect name for a virtual reality device, but they rebranded this one not to be the Oculus Quest, but the Meta Quest. It's like, come on, like just leave Oculus. It's perfect. Anyhow, and they renamed the whole Facebook parent company to become Meta, right? And as you probably have seen, they want to build the next version of social media. And for this, they're building things like Horizon Worlds, which are these open virtual spaces where you can go in as an avatar represented, hang out with your friends and do some stuff, or workrooms, which is more for business meetings. But in the end, of course, you know what Facebook is doing, right? Or Meta in the end. They want to get a lot of user data to basically have more targeted advertisement in the end, right? So always got to be careful with this kind of a stuff. And yeah, always be careful with what you share and stuff like that, right? Horizon Worlds, again, I'm looking forward to use it. It's only available in the US and Canada, but I think could be pretty interesting. But of course, Microsoft also has a really good solution there, and actually much longer than Meta. Altspace VR was acquired by Microsoft 5 years ago already, and you can have similar virtual worlds with virtual avatars, and can have business meetings inside of it, but also have these large events, right? Like just last year, they had the Ignite keynote as part of Altspace, or in Altspace, they had the Ignite keynote there, and it was fantastic. They had like 10,000 people joining, and I was also there in VR, and I remember meeting some MVP friends, but also other contacts from the industry before this keynote actually started, right? So you put on your VR headset, and then you look right next to you. Oh, you see your friend Bruno, for example, right? Hey, what are you doing? And then your fully virtual world, but you're fully immersed, right? Stereo 3D vision, spatial sound. So you're fully inside of it, totally focused on it. And just like if you would go to a real event where before the session or keynote starts, you would probably take a seat and have some conversations with your friends sitting next to you. The same thing happened in these kind of virtual experience in OnSpace, right? Which never happens if you're just doing an online meeting in whatever meeting tool. And so that's high value for events, but also these kind of business meetings. And again, you can use it cross-platform, and you can use also do panels or fireside chats. Here you can see Alex Kipman on the right-hand side. Left-hand side is my old Altspace avatar. And we did, as part of the MR Dev Days 2 years ago, I think already, this kind of fireside chat, right? And it was great. It was, again, much more immersive, and a lot of interesting things you can do there. The economy is also growing. Like I mentioned before, here's another quote from Facebook from the report recently. Like I mentioned, Qualcomm basically said, hey, we think it's 10 million Quest 2 devices they've sold. And but officially from Facebook, we know $1 billion were spent for the Quest store, right? If you want to buy apps or games for the Quest, you do this on the Quest store. And apparently, if you do the math, it's $100 per user, which is actually quite a bit for each user to pay for, right? So growing market. And again, I think this is quite significant. If you look at how much people pay for mobile games or apps, like $100 per user with that short time is actually quite a bit. And of course, I just talked about these centralized platforms like Meta and Microsoft, and other big tech players are building, like NVIDIA Omniverse and stuff like that. But you also have these startups that are building decentralized e-commerce and decentralized metaverse platforms. Just to name three is Decentraland, Sandbox, or Sonium Spaces. And in these decentralized, basically a lot of blockchain technology involved, of course, you can actually buy virtual land. You can buy virtual real estate. And they sold, as you can see on the screenshot, a piece in Decentraland for $2.4 million, right? Which is interesting if you think about like what you would probably did pay not that much in the real world. But anyhow, it's yeah. Also, the kind of advertisements, like here you can see they are selling virtual ad banners, 70K for this virtual ad banner. I mean, good for them, but of course, we got to be real here, right? This is highly speculative, also driven by cryptocurrencies and the speculation there. This will bounce back for sure. This is a bubble. It will bounce back. I have no question about it. But there's substantial pieces which are good, and they will stick. And I think decentralized asset exchange, whatever the protocol underneath is, it's a blockchain or whatever, I think these decentralized and open interoperability between these platforms is actually a key piece we need for the metaverse. We want to take our virtual avatars, we want to take our virtual fashion, we want to take all these things with us if we go from this metaverse space to the other metaverse space, right? What we don't want is walled gardens again. And so that's why I'm saying these decentralized pieces have really is a key element, of course. But again, we're just getting started. A lot of speculation all over the place, but I think it will bounce back to a healthy state at some point. Okay, so we have these full virtual worlds, right, which we talked about. But I'm actually even more excited about a thing Niantic, but also myself before that, called the real world metaverse. And so I mentioned to you, we have these devices, could be phone, could be HoloLens, whatever it is. All of them sense the world around us, right? Like these devices know my room, they know my place here where we live, because I used it there and they scan this place. Now think about, we have these 2 million devices, right? What about if we combine all the spatial sensing, the spatial mapping data from all these heterogeneous devices and merge it together? Look at this. We get the digital twin of the world. We get this digital content layer, this replica of the real world. And if we overlay that on the physical world, we get the real world metaverse. Because we have this kind of a computer vision reference map of the whole world, or at least the most parts which are urban areas and things like that. And with this information, we can basically pin or anchor certain virtual information there. And technology, for example, Microsoft Azure Spatial Anchors are very good and leading the path here for sure. They're way ahead of the competition. They allow you basically to do this. You can put virtual anchor points in these kind of physical worlds, right? And here's an example of what I did. Here's a kind of I call it a time machine portal or AR historic portal, whatever. And this is in my hometown, Dresden, where I put an old video and overlaid it on the current scenery. And you can see, for example, the church towers there in the background, the two church towers. Dresden was bombed in World War II, so a lot of things were rebuilt, but not everything. And you can see it looks a little bit differently in that direction where there were the Sophia Church before. And so what I did here is I basically used Azure Spatial Anchors. I created an anchor point, a virtual anchor point at the location, and I attached this video to it. And this is thanks to the real-world metaverse data the spatial anchor system has, right? And with this, now another user like you could come there with your phone, if you have the app, of course. You just go with your phone or with a HoloLens, scan the place a little bit. It will recognize and relocate and will load you the information and show you this video at the exact same location, right? And again, we're talking about 5 to 10 centimeter range precision here, right? If we would use GPS, it would be meter range, right? It would be way too off. Also, of course, this works indoor because it's based on computer vision, analyzing camera data. And of course, this also doesn't require any marker, right? No AR marker, no QR code, no GPS, nothing like this needed. Just the real world that becomes your marker and that can be re-recognized again. And you can load information and you could put a photo, a video, a 3D model, of course, anything you want. And it could also be a look into the future, right? But anyhow, this is just one example. And of course, a lot of companies are working in that space. I mentioned Snap, of course, very active here with their large computer vision team, in fact. And they have things like local lenses, connected lenses, and they provide you these kind of experiences here, as you can see in a moment, where you can, I keep on talking about it since a few years, like 3 or 4 years, right? The real world becomes your canvas. And that's exactly what you see here in the demo video. But you can see, right, with this kind of real world metaverse and spatial anchoring technology, we can share information across devices and over time, right? We can persist it there. And this is only getting started with mobile phones. You see, these are the Spectacles developer devices, which are already going into a smaller form factor. So much more stuff going to happen there. And like I said, Niantic, known from Pokemon Go or Harry Potter and other geolocation-based AR games, is also working on this. And as you know, they already have quite a large user base, right? So they have a lot of information already from their kind of users, how they are using these kind of experiences and created this kind of spatial map from the real world Metaverse data, right? And that is interesting. And now we have an SDK where we can actually leverage it, right? So we can build experiences on top of it. And here you can just see one example in my garden. I'm using the Niantic SDK here just to scan the world. And then here you can see the overlay that is created, the meshing. And this is the real world Metaverse visualized, if you will, right? In the end, or at least part of it. And here you can see how it reconstructs environment, and then we can have some interactions, right? I can shoot these meatballs here, and they virtual meatballs, and they physically behave correct in the real world. And so interesting stuff. And this is just on an old Android phone, so really getting interesting. Another part is, before we switch to quantum, of course, I want to talk also about the robotic part. There's a lot of information here when we think about the real world metaverse, also with robotics. And you have experiences here which are really interesting, where we can have these robots, like a Boston Dynamics spot here, that shares the same spatial map now, thanks to the Azure Spatial Anchors ROS SDK. So there's a robot operating system, ROS, and there is an SDK from ASA for Azure Spatial Anchors, which means we can share the same real-world Metaverse data, the spatial anchoring data, between the robot and the HoloLens or the mobile. And so we can actually control it, right? We just put on the HoloLens and tap this, that, and then the robot will move there because they share the same map, right? Interesting stuff. And I think this is really the real interesting part, where we combine this virtual with the real world. And well, of course, I had to put here Satya Nadella's quote, because I think it describes it very well. That we, with the Metaverse, we're really embedding the real world into computing. And this is a key element, I think, and because otherwise we're just dealing with online games again, right? Well, like I said, we can have also a bunch of these business meetings, and Microsoft is working on, as you heard, an announcement last year on the Mesh platform, Microsoft's Mesh platform, which is pretty exciting because it allows us developers to build custom Metaverse apps all on the Mesh platform, which means they can all interrupt between each other, right? So this is awesome already, and we get a lot of functionality. Like, look at this multi-user sync when we do the high five here. Look at this. There's no delay, right? And like I said, I'm in Germany, and this was with a colleague that is on the West Coast in the US. So thousands of miles or kilometers between us. And the multi-user sync with the high five, no delay. And we get collaboration tools. We get virtual presence, like we can create avatars, right? But also holoportation, like 3D video. We can bring in 3D models, locally rendered or remotely rendered. So you have a lot of flexibility, a lot of building blocks, which you can leverage, and all of this device-independent cross-platform. And I'm excited because, like, at some point we can, of course, build our custom applications on top of it, right? And this is part of the Mesh ecosystem in the end. But even more so, I think, is the Mesh for Teams interesting, because it's kind of a gateway into the Metaverse, right? Mesh for Teams is basically going to be delivered to the 270 million monthly Microsoft Teams users. And so they get this kind of an early experience for these Metaverse experiences. We're going where the customers are in the end, right? And here you can see that the Teams window, and well, you can create these virtual corporate spaces, and you also represent it as a virtual avatar, of course. And that's going to be pretty interesting, I think. And I tell you, I experienced a bunch of these things. Also, we had a bunch of business meeting in various platforms for hours, and it's much more immersive. First of all, you're much more focused, right? Because you put on the VR headset, you see the virtual reality world, you hear spatial sound. So if someone is talking over there, I know that it's talking over there, and I will turn my head. And so all of this is super interesting and provides real meaningful value. And I memorize much better from these immersive meetings. But again, virtual presence, important part of it. Like, how are you represented in these virtual worlds? And this is very different at the moment, right? You have all these different avatar systems. Like, this is just 3 times Renee in different platforms. And of course, that's very much different now. And that's a challenge, because like what you really want, you want to be seen as the same avatar on each of these platforms, right? Just like your profile picture on social media, you also want to take the same profile picture on each social media platform. But with an avatar, that becomes a little bit more complicated. So I think this is also an opportunity for decentralized identity systems like, for example, blockchain or Web3 stuff, where we can have a decentralized identity, and maybe we can attach our avatar as an NFT, a non-fungible token, right? Basically a link on the chain. Okay, Rene owns this kind of piece, but in the end, it's not the real avatar on the chain, but just a link to the avatar. But at least on the chain, it mentions, okay, this is my identity. It's decentralized. I don't need a platform. I don't need Facebook to log in or whatever. It's decentralized, and I have my NFT with my avatar, right? So maybe that's going to happen. I hope so. But this is really important, because otherwise we will look very differently on each of these platforms. And in the end, what we want is one metaverse with interop, and not just walled gardens, right? To wrap it up, basically, we can categorize the metaverse a little bit into different use cases, but also the virtual and the real world, right? The virtual worlds, like I've shown initially, is of course super interesting for consumers, but also enterprises will get a lot of value out of that. I think with these corporate spaces, you can have immersive spaces where you can meet your clients, or we already see that with certain brands, or you can create kind of a business meeting, and impactful also onboarding for new employees is going to happen in this hybrid work, right? And so interesting pieces are also for these virtual metaverse solutions in enterprise. But I think enterprise will gain the most value out of these real world experiences, because we can have virtual dashboards in manufacturing factories, and so much other things that we cannot even think about today, right? Let's make a short break here, a mental break only, because we're going to talk about quantum computing. Like I mentioned, it's a distinct topic from spatial computing and the metaverse, but quantum computing and the sheer power of computing we will get with it will be pretty important, actually, to run these large simulations, and also for things like true randomness and a couple of other things, right? Okay. Like I said, quantum computing means two things: hardware, these large, crazy machines. By the way, Microsoft just achieved an amazing milestone, they achieved an amazing milestone and released a blog post yesterday, a part of the topological qubits approach that Microsoft is choosing for the quantum hardware. Super interesting. If they move forward with it, they can win the game here. Pretty interesting. But also you have players like IBM, of course, very active here, but also Atom Computing, Rigetti, D-Wave. I'm sure I forget many. Honeywell, Toyota, so many are active in this building quantum computing hardware. But we are going to talk more about quantum computing software today. But also, of course, I will explain you the basics. What is the basic of computation actually there? But one thing you should keep in mind, quantum computing will basically make today's unsolvable problems that are computational too expensive solvable, and all of that in polynomial time or in linear time. And so this will probably be the most disruptive technology that we will see in the next decades in the 21st century. Because again, not all problems will be solved, but a lot of these huge computational complex problems will be solvable with it. And so what is it actually doing? Well, quantum computing is based on quantum mechanics. And in quantum mechanics, you can have a certain phenomenon. You can observe these certain phenomena like superposition and entanglement. And quantum mechanics is basically a discipline of physics. And it was I think it's 100 years old or something like this. Probably something like this. And you have basic quantum mechanics describes how the smallest particles we know in our universe behave. Like think about atoms or ions or subatomic particles like photons and electrons and so on, right? And so quantum computing describes how these behave. And again, at this smallest scale, you can see these weird phenomena like superposition and entanglement. So what is superposition? In classical computing, we have this digital information, right? We have a bit. And a bit can be 0 or 1, like off or on, right? And in quantum computing or in quantum mechanics, we can actually leverage the phenomena of superposition, and we can build something which is a qubit. And a qubit is more, think about it like a bit is fully digital, and a qubit, think about it, it's more analog. Of course, that's not the 100% scientific definition, but think about you still can have 0, 1 with a qubit. If you look at the visualization here, it's basically a sphere. The sphere is called a Bloch sphere. And in this Bloch sphere, of course, if it points to the North Pole, it's 0. If it points to the South Pole, it's 1. But as you can see, of course, it's three-dimensional and it has multiple states in between, right? And if you put this qubit into superposition, which you can do with different mechanical things, like typically lasers, right? And you can take this particle, like let's say we're using ions, like trapped ions or something like this, or we could also use neutral atoms these days, or whatever, right? You take this particle, you can trigger it so it gets into superposition, and basically what this means is at the same time it can represent multiple states. Sounds crazy, but it works. Like, so you can represent multiple states at the same time, and then you can use another phenomenon called entanglement, where you take one qubit and entangle it with another qubit, and then you can take another qubit and so on, right? So this is what you oftentimes hear as a metric, is amount of qubits they can have, right? And so what means if you entangle a qubit with another qubit, if you apply a certain change to one qubit, it will also be applied to the other qubit, although they might be physically at a different location, right? So there has been experiments where they have proven, in fact, photographically, even if you take these qubits, if you separate them and apply a change to one qubit, the other qubit will have the same change applied. And what you can see here, in fact, is a screenshot of the first photographic proof of entanglement that was done a few years ago. And they used, as qubits, they used photons. You can also use them, of course. And what they did is they entangled two photons together, coming out of a laser, then entangled them, and then basically were splitting them up. One qubit was going photon in this direction, another one in this direction. And to one of them, they applied a phase shift. And the other one didn't get the phase shift applied. But guess what? Here's actually the experiment. So left one got the phase shift applied. This one didn't get the phase shift applied. They measured both at the end, both at the same phase shift. Crazy, right? Crazy stuff. And Einstein actually called entanglement a spooky action at a distance. He still, until he died, he still wasn't sold on it. But after his time, basically, a lot of experiments have proven this is in fact the case, right? So we can use qubits, right? We can use superposition, we can use entanglement. And with all of this together, you can imagine we get massive parallel computing power. And so we can compute and have a search space and search it in parallel in multiple things at the same time. And so you can do really, really impactful things for these super complex problems. Of course, Microsoft is also heavily working in that space with their Azure Quantum offering. And you have a Quantum as a service, for example. With Azure Quantum, you can basically rent computational time on real quantum hardware. Azure Quantum is actually a lot more, but we're not going to dive too deep into this because I said it's just an intro. But here you can see on this video, there's a bunch of real hardware providers where you can basically use quantum as a source. So you think about, you can write your quantum solution, you can write your quantum algorithm, and then rent computing time on one of these machines, on real quantum computers. And you don't have to buy $1 million machine and put it in your house, right? You can rent computing time, and that's thanks to the cloud and quantum as a service. This is huge, right? But also you can also have simulators. So even if you don't want to use a real quantum computer or don't have the money to do this, you can use a simulator, which is much cheaper. Of course, also a little bit more limited, but definitely good to simulate certain quantum things on a simulator that can run on FPGA or GPU or whatever the simulation runs. And larger, even more important is also, of course, Microsoft, or not even more, but also important is Microsoft's other very strong standing in the developer tooling. And so you have a new language called Q#, which is dedicated for quantum algorithm design. And you also have the QDK, the Quantum Development Kit, which is a development kit, for building quantum algorithms. And a lot of interesting other stuff. And like I said, Microsoft is also working their own quantum hardware computer, and they just achieved a great milestone with topological qubits, or building blocks of topological qubits, right? All right, what are some of the key areas which I think are really impactful today already? Like, we have 3 key areas where we're already seeing quite some impact with quantum computing. And first of all is quantum machine learning. Again, apologize, a little bit of a cold here. But quantum machine learning basically, is machine learning, but with quantum and with quantum computers. And in fact, I had a really interesting conversation in my QBytes video series with a with experts in QML, quantum machine learning, and basically they built an image classification model, and they didn't build the whole neural network in a quantum layer. So not the whole neural network was built with gates and quantum algorithms, but in fact only the one of the last layers. So it's a hybrid approach, right? You have most of the neural network is in a classical way, and before the output layer you have a hybrid kind of approach where you have a quantum layer inside of it. And guess what? They achieved better accuracy and higher speed, even with the small infancy quantum computers we have these days. Why is that the case? Well, I told you the qubits superposition, right? They can represent this data much better because they can represent multiple states at the same time. And so works really well, and high research topic, of course, also for natural language processing and so on. Another field which we're going to talk about is quantum optimization, which is going to help us optimize complex problems like schedule optimization and so on. And third is quantum security, which can be a threat, but also an opportunity. Let's talk about the quantum security opportunity first, which is quantum key distribution as one example. What quantum key distribution means is basically you can use this quantum phenomena to securely exchange symmetric keys. And so look at this example where we have our classical Alice and Bob characters, and they have a quantum channel established between each other. And now they want to send this shared key over the quantum channel. Not encrypted, nothing, right? Just over the quantum channel. And well, there's Charlie in between. He's going to eavesdrop, and he will get the key. Oh, man, what happens? Well, Bob will know that Charlie got the key because we sent these keys as qubits in superposition. And you have to know if you want to measure, if you want to read it out, the value. These qubits will collapse into like a base ground state, right? So the superposition will collapse. And this is a physics phenomena you cannot change. And so basically, if Charlie is going to eavesdrop, Bob will know because the state already collapsed of the stuff he receives, right? So what they do is they will drop the key, repeat it until Bob knows, hey, I'm the first one measuring it. I'm reading out the key. And so this is a good way to exchange a key. Then you can use it to encrypt the data and send it over a faster classical channel, right? Interesting stuff is already happening there in that area because a lot of quantum key distribution backbones are being built at the moment, because you can imagine this is oftentimes being used with photons as qubits. And so it's fiber channels, but these fiber channels cannot have a repeater, because then you would have to read out the value, and you know what I just explained. And so they have to build these special layers, and they just achieved an achievement in Japan, a 600 kilometer long quantum key distribution channel, right? You also have key distribution hardware, and it gets even crazier. China, but also the European Space Agency, NASA, of course, all of them are experimenting with orbiting satellites for quantum key distribution, because you can also, of course, wirelessly exchange, and you have much less atmospheric scattering if you send it directly instead of wireless transfer on Earth, right? So interesting. Maybe in a few years we will have satellites orbiting, providing us a super secure communication channels. And also with quantum, we have true randomness. With classical computers, we have just pseudo random numbers. And this is actually an interesting screenshot here I took from Philip Morel on Twitter. And you can see on the left-hand side, this is pseudo randomness, right? You see actually patterns here. It's not really true random. This is true quantum randomness. And this is, again, based on this quantum physical phenomena, right? So you can have true random numbers, which are very important for cryptography. And the fourth piece is, and this is the threat we're facing with quantum computing, is it is a threat for today's cryptography. And that's why there is this kind of motion of DevSecOps, just like DevOps, but with security. You can implement things like crypto agility. For example, make sure that your certificates and your cryptography services are in such a state that you can quickly switch out the cryptography algorithms, right? For example, right now, RSA 204080 is oftentimes used, but it might be cracked at some point, and you want to make sure that you're able to switch it. And this is where crypto agility comes into play. And of course, at some point, these quantum computers will crack today's cryptography, right? Good news is there is also a lot of research when it comes to post-quantum cryptography. So a lot of development happening there, and really interesting achievements. And I think in the next couple of years, we will see post-quantum algorithms that can actually be implemented that are resilient to quantum attacks. But RSA, as an example, with a high key length of 204080, will be able to be cracked. There is a quantum algorithm that is called Shor's algorithm that is able to kind of crack these keys. Of course, with the infancy of quantum computers we have today, it would take a very long time. And you can see here on the chart a little bit, like on a classical computer, it would take like 300 trillion years, longer than the time of the Earth, right, to crack OS A204080 key. But if you're looking at a thing like, for example, a quantum computer that has 20 million noisy qubits, like the bottom here, the 20 million noisy qubits, it will be able to crack it in a very short time. Or if we have around 4,000 stable qubits, it will take 10 seconds. Like if we have a quantum computer with 4,000 stable qubits, which is still many years away, right? It will be able to crack this in a few seconds, right? So this will happen. And so prepare for this thing called Q Day, the day when quantum computers will make today's cryptography obsolete. That might also be applicable to other things, but cryptography is the basis of our secure internet communication. HTTPS, financial exchange, messaging, all of that is based on this. And IBM has a 127 qubit computer. And by the end of next year, I think they want to have a 1,000 qubit computer by the end of 2023. And experts basically say, when is Q Day going to happen? When will this kind of break happen? Experts say it could be 5 to 40 years. So we'll see when it happens, but it's going to happen. And I'm pretty optimistic it will actually be in this decade. So buckle up and prepare yourself. Quantum and smart optimization. Last topic here before we open it up for Q&A. I mentioned quantum optimization, but in general, what is optimization? Well, you have a thing called an objective function. Think about, if we're talking about physics or other systems, think about an energy function. So you want to reduce the energy you put into the system while maximizing the output. Same thing if you want to do investments and things like this. So you want to find the global minima. But oftentimes with optimization algorithms, they need to search, like this is just a 2D image, right? But think about what we're searching is not even a three-dimensional space, but it's a multi-dimensional space. And we want to find the global minima. And this is very complex, NP complex typically. And you have a lot of classic optimization algorithms, but with quantum-inspired optimization, I can actually build quantum algorithms that, again, use quantum algorithmic code. But again, I can run these on simulators. And even on these simulators, I achieve better results than today's optimization algorithms for certain cases already. And so optimization with quantum computers will be super important for cases like fleet management and logistics, like, workforce scheduling, or engineering and material science discovery, life sciences, chemistry, like think about COVID or other drugs. COVID is not a drug, right? But they want to understand, like, for example, how the S protein folds. And this kind of protein folding is very common for life sciences and a very challenging problem, and also super complex. So quantum computers will also provide some interesting opportunities here. But of course, also financial investments, right? Like think about portfolio management, asset pricing, risk analysis, all of this today. I can tell you I was attending a conference for quantum computing last year, and there were a lot of financial institutes among those. And one guy giving a talk was actually saying, hey, if your financial institute is missing to jump on the quantum computing wave, they will be obsolete in 10 years, right? So they definitely see the need here to be on this. One use case we developed with a client called Enel, which is one of the largest energy grid providers in the world. And so they own these kind of energy transformator stations, the wires and all of it, the energy grid in the end. And they have this huge workforce of, I think, 20,000 field service workers. So they have 20,000 people that go out every day to do repairs, to whatever maintenance they have to do. And as you can imagine, they have certain tasks they need to fulfill, right? Also stops on their route. And it's, of course, a huge complex problem, NP complex problem. You probably heard about the traveling salesman problem. That's it in the end, right? So you want to optimize that they don't spend too much time on the road, but maximize the time they spend working. But also, of course, in the end, you can enable them with much more free time, right? It's not just for squeezing out the last piece of efficiency, but actually make the life better with it because they don't have to waste time on the road. And so complex problem, you currently have certain optimization algorithms that can do this. But we developed a solution with a quantum and spot algorithm, which we call MegaQubo. It's a quadratic unconstrained binary optimization. And this has implemented this kind of solution with quantum algorithms. So quantum algorithms are being used here to define the problem. And we run it not on a real quantum computer, but we run it on a simulator with GPU arrays, like a GPU cluster. And already with that, we achieved a 20% reduction of travel time for these 20,000 field service workers, right? Just imagine the sheer number of money and time that is being saved for these folks. And again, this is with a quantum simulator. Now think about if we take this same approach, once there's a powerful enough quantum computer, we can run it on the real quantum hardware and it will just fly. And so that's an interesting part, I think. Also, other optimization pieces, we have been taking part of the Airbus Quantum Computing Challenge 2 years. Actually won it. These guys did actually a solution where they're optimizing the load of a plane. So think about a cargo plane or whatever plane you want to optimize the load. Super complex problem, lots of constraints, physical constraints. And yeah, there's a bunch more. We also had a paper released, a bunch of other things, and yeah, many, many more. Last thing I want to mention here, a little teaser here for my video series is we want to learn more about quantum computing. I have this little video series called QBytes where I interview experts in quantum computing and talk with them about a certain topic. And these episodes are only short, like 10, 15, or 20 minutes. And we have one topic, typically 3 questions, have a conversation with a true expert. And the goal is to make quantum computing approachable for everyone and also to show the impact we can already achieve today. And because right now the field is a little bit, I study computer science, so I'm a computer scientist, right? But you also have folks that, of course, in the quantum field, a lot of PhDs in physics and quantum physics and so on. And what I try to do with the show is to be a little bit of a translator, right? To make it approachable and inclusive for everyone. And so if you want to learn more, I'm just about to record the last few episodes of season 5, and we just published season 4 completely. So we already have 40 episodes to take a look at and learn a little bit more if you're interested in it. And with that, I'm at the end of my presentation here. I thank you so much for your attention. If you have any questions, we still have 8 minutes or so left to go through those. But final words is, I think it's an exciting time. We have spatial computing, the real world metaverse, and all of these amazing things we can build already today. And then we have this new technology, this quantum computing, which is going to fully change how computers actually work in the end with quantum computers. And we can solve today's unsolvable problem in linear time. And if that is not something, I don't know. But one thing before I forget, I want to make sure folks understand that quantum computers, like your smartphone in your pocket, won't be a quantum computer anytime soon, right? Probably never. Because quantum computers are very good at solving very specific problems. Like I said, these chemistry, large search space, and so on. But quantum computers won't replace classical computers. We will still have semiconductor-based classical computers, of course, for controlling quantum computers, but also for the general things we have to do. But quantum computers are very good for very specific problems, which we cannot solve today. And it might even help to solve the large problems we face as a human race, like climate change, climate simulation, and whatnot. And so that's why I'm excited about these kind of technologies, because they will make the world hopefully better. Thank you for your attention. Okay, we have a question. Oh gosh, we have so many comments. Okay, greetings, Renee. Okay, I'm just going to read these questions and going to, oh, there we see it. Okay, folks, you see the question there, I guess, but I'm going to read it out anyway. Greetings, Renee. What app are you using to drop AR videos on the street like that for other users to find? Is that Snap and then Snapchat? No, this is not Snapchat. This is a custom app I built on top of Azure Spatial Anchors. So under the hood, it's using Azure Spatial Anchors, and yeah, that's it. Custom app, basically. What is the link for the QBytes? Okay, good, very good questions. I'm going to put a link here. Just let me quickly find the link. This one, yeah. Okay. Oh, I can just share it also on screen, right? So just go to this URL. You can go to our website. Just search reply in QBytes, and then it should pop up pretty much at the beginning. But I'm also, I don't know if I can send it here. I can also post it here on the private chat window. Maybe Alexia can also help to spread this out. Okay, next question. Hello, my question is, do you think quantum computers will have large commercial applications? In other words, could a layman use quantum computers in the near future? Probably not the layman could use quantum computers in the near future, but everyone is working on that very heavily. So from development standpoint, if you look at the QDK, the Quantum Development Kit, and Q Sharp from Microsoft, they're going to make this much easier to build quantum solutions. You also have a lot of learning things like the quantum cutters and Microsoft Docs. You can find a lot of Q Sharp examples. And so this will become easier to write quantum computer code, but access to these devices will still be limited. And that's what I showed earlier, which is exciting, that we can use QaaS, Quantum as a Service, in the end, and can basically provide these kind of quantum computers, but you can rent computing time, so you don't have to invest these millions of dollars, right? But of course, commercial applications, a lot of those, and like I said, there's already certain commercial applications available. Like we developed a few actually for clients for optimization with quantum-inspired optimization in the end. But of course, it's still in its infancy, and I think much more of these applications will arise to solve very specific problems, though, right? So, like I said, it won't be the computer we all use every day. We'll still have classical computers, but for very specific problems, especially in science and very NP complex problems, these quantum computers are the only solution we can actually solve those. Okay, another one. There we go. There we go. Do you assert that those that first solve some of these complex problems will then become a marketplace dominate again? Good question. Maybe, I don't know. It's like, the kind of approach a lot of companies are taking at the moment for quantum hardware is, first of all, developing the quantum hardware and getting also these are often scientific apparatus, right? And turning these into commercial hardwares that is working reliable. And you don't need, like at the moment, like a lot of these quantum computers, they require lab staff. They need to set it up, and you just don't turn it on, right? It's like a lot of things that need to be set up and calibrated and whatnot. And so only if we can solve those, then we will have true commercial applications, I guess, for everyone to use. And it's an arms race again, right? Especially if we look at the threat I mentioned with the kind of quantum threat with cracking RSA and other encryption algorithms. It's an arms race also between countries, and we'll see who's going to be the first there. I don't know yet, but yeah, surely it will still be dominated by those that are the first. That's typical. I'm sure though that there will be constraints that will make sure that also these kind of quantum as a service will make it available for many more people in the end. But who knows who's going to build the best quantum computer? They don't even know what, or there's not even, it's still uncertain at the moment what is the best approach. Is it topological qubits? Is it trapped ions? Is it neutral atoms? What's going to provide us the best kind of quantum computer? We'll see, but I'm sure we will see in this decade. Okay, last question, I guess. Captain Kevin. And do you think AR has come along far enough to where automobile and DoD officials will start implementing the hardware and vehicles more, to where we will see road signs and AR through the windshield? Oh yeah, for sure. In fact, you see this already with certain cars. Let me think about it. I think Audi e-tron or Q-tron, Mercedes-Benz S-Class, and VW, Volkswagen ID3 and ID4 have actually such an enhanced AR HUD, like a heads-up display, right? We all know the heads-up displays in cars. You probably have seen it. typically it's just a projection of your like speed, and basically the same thing you see below. You in the console, you can see it also right in your windshield. But what the cars models I just mentioned, they have the advanced version where, especially with the ID4, you can Google it actually. They have this. They are sensing the in front of them basically, and they will project you like navigation arrows right if there would be in the street in front of you. So they're not just doing the flat 2D projection on the windshield, but they actually project it in such a nice way because they recognize the scenery and all of that. So it looks like the arrow is right in the street there, correctly projected prospectively. So this is already there, and I'm sure it will just grow more.
Not
You're
sure you
muted.
can hear me. There you go. I was saying thank you so much for coming in today. This was a great session, and lots of interaction in the chat, lots of questions. So that's absolutely awesome. I'm just going to put in one more slide here. I shared in the slide in the chat earlier our link to our survey if you'd like to share your experience for today's session. The event code is 15421. And finally, join our community. We also shared the Reactor YouTube channel in the chat, the link in which you'll be able to access this video on demand as it is being recorded. You can also follow us on Meetup to get more events and be aware of what events and sessions are coming up soon. We're also on social media, so feel free to join us. Yeah. Renee, thank you again so much. I think this is the end for today. Lots of great comments here. And yeah, it keeps on going. Thank you so much. We hope to have you again very soon.
Bye-bye. Thank you for having me. Have a great
Bye.
one.